So what if I told you that an 800-year-old Chinese stretching routine is actually outperforming some modern pharmaceuticals right now when it comes to lowering blood pressure?
Yeah, I mean, it sounds like total magical thinking at first glance.
Right. Or, that just standing in front of a painting in an art museum can measurably alter the biological aging of your cells.
Which is wild.
Okay.
But what we're really looking at here is the mechanism of human health finally coming into focus. We're, acquiring the data to understand these invisible systems that have just been working in the background all along.
And that is exactly what we are unpacking today on the deep dive.
Absolutely.
For those of you listening, whether you're prepping for a big meeting or maybe you're just feeling utterly overwhelmed by the daily avalanche of doom and rage in your news feeds, this deep dive is basically your shortcut to feeling genuinely well-informed.
Yeah, it's a breather.
Exactly. Today, we're taking a comprehensive look at the factual state of human progress, and we're drawing directly from edition number 21 of the Bright News Daily Newsletter. That was published on May 18th, 2026.
Just to give you a sense of the scale of this data, right? This is not just a handful of feel-good anecdotes.
Not at all.
We're looking at a curated digest of 4,402 positive stories, and they're pulled from 25 monitored global sources.
Which is just so refreshing to me, because this digest proves good news isn't just fluff. We aren't talking about cute videos of cats.
Right, no.
We're talking about hard science, massive ecological recoveries, global breakthroughs. Our mission here is to sort of sift through the noise and uncover what is actually working in the world today.
Yeah, and when you look at all 4,402 stories in aggregate, a really fascinating underlying pattern emerges.
What's the pattern?
Well, humanity is actively shifting from a state of blind reactive consumption to an era of incredible high-resolution understanding. Like, we are finally mapping the structural systems around us.
I love that phrase, high-resolution understanding. Let's dive right into that, because to grasp this new era of progress, we first have to look at how science is suddenly illuminating the invisible forces that basically govern our reality.
Oh, absolutely.
And I mean from the absolute depths of the ocean all the way to the edge of the universe. So let's start with the cosmic scale, actually. Astronomers using this Wiki Transient facility have just captured the very first direct image of the cosmic web.
Which is just a monumental shift in astrophysics.
Right.
Because for decades, astrophysicists knew that galaxies weren't just floating around randomly. They hypothesized that these massive filaments of dark matter and gas acted like highways, connecting galaxy clusters.
But they couldn't see them.
No, we could only infer their existence through gravity.
Exactly. It was just theoretical math for the longest time. But now they have actually imaged it. They captured the faint fluorescence of hydrogen gas being illuminated by distant galaxies. It's sort of like finally seeing the silk of a spider web because the morning light caught it at just the right angle.
That's a great analogy.
Thanks. We aren't theorizing the structure of the universe anymore. We are actually looking at the highway system. But then if you zoom all the way into the microscopic level, the exact same kind of structural discovery is happening.
It really is.
Like, researchers at St. Jude just found a hidden small RNA in the cholera bacterium that determines its ability to infect humans.
And we should break down how that works because it's brilliant. We usually think of bacteria as these static, always-on threats.
Right. It's constantly dangerous.
Yeah. But this small RNA acts as an environmental sensor and kind of like a switch. When the cholera bacterium is floating out in the water, the RNA keeps the bacterium's toxic proteins locked down.
Oh, so it saves energy.
Exactly. It saves energy. But when that RNA senses the specific temperature and acidity of the human gut, it unravels. It flips the switch, turning on the bacterium's virulence.
Wow. And if we know where the switch is, we can figure out how to jam it.
Precisely.
And it's not just in space or in a microscopic lab either. Look at conservation. Scientists are now sampling floating DNA, which they call eDNA, in seawater.
Yeah, the eDNA stuff is wild.
It is. They are pulling a liter of ocean water, isolating the genetic material shed from the scales and mucus of marine life, and literally just running it through a sequencer.
And they aren't just using it to see if, a single dolphin swam by.
Right. They're using it to accurately monitor the overarching health, the genetic diversity, and the migration patterns of American dolphin populations. And they do it without ever having to capture or tag a single animal.
It essentially acts as a biological barcode scanner for the entire ocean.
Yes, a barcode scanner. And then Then you have geology. Scientists have been baffled for decades by this mysterious underwater fault line near Ecuador.
Right, the one that acts like clockwork.
Yes, they just discovered it has these hidden breaks built into it. This fault produces nearly identical magnitude 6 earthquakes every 5 to 6 years.
And the mechanics of those breaks are just fascinating because it's a subduction zone where one tectonic plate is sliding under another.
Which is usually really dangerous, right?
Exactly. Usually when plates get stuck like that, tension builds over decades or centuries until it just snaps.
Like a massive civilization-threatening magnitude 9 earthquake.
Yes. But off the coast of Ecuador, the seafloor is heavily scarred with seamounts. They're essentially underwater mountains. And these mountains act as friction bumps.
Oh, wow. So the plates catch on the mountain, tension builds for just 5 years, the mountain shears a little bit, and it triggers a magnitude 6 quake.
You got it. It actively prevents a massive earthquake by constantly bleeding off the tectonic pressure. It's an automatic release valve, basically built into the Earth's crust.
See, it honestly feels like science just got a massive software update that lets us finally see the actual source code of the universe.
Well, I love that.
Right, from cosmic highways to geological breaks to microscopic DNA floating in a splash of seawater. But let me push back on this a little bit.
Sure.
With all these hidden systems suddenly being revealed, does this mean our previous models of science and conservation were just fundamentally blind?
Well, I wouldn't call them blind, but they were certainly operating in a low-resolution symptomatic mode.
Okay, symptomatic.
Yeah, we were practicing observational science. We saw an earthquake happen, and we recorded the tremors. We saw a patient get sick with cholera, and we pumped them full of fluids. We saw a dolphin surface, and we put a tally mark on a clipboard.
Right, very reactive.
Exactly.
Yeah.
What you are describing now is a fundamental leap into structural science.
So we are mapping the architecture.
Exactly. Knowing the why and the how allows us to move from reacting to disasters to actively predicting and managing them.
And here is where the shift gets really practical for you listening.
Yeah.
That structural understanding isn't just happening out in the deep ocean or out in the cosmos. It is happening right inside our own bodies.
Yeah, this is where it hits home.
Modern science is turning its high-resolution lens inward and uncovering the biological mechanisms behind everyday things. But to understand the human body, we first have to recognize how incredibly complex our machinery really is.
Oh, definitely.
Like, the newsletter highlights this stunning fossil discovery in Ethiopia that is currently just reshaping our understanding of human survival.
That Ethiopian fossil find is crucial. It shows that early Homo species and a previously unknown Australopithecus species actually lived side by side
Wait, like in the same environment?
in the exact same environment,
Yeah.
roughly 2.6 to 2.8 million years ago.
Which completely shatters that linear monkey-to-man evolutionary chart we all had in middle school biology, right?
Oh, totally. Our evolutionary roots are incredibly tangled.
Mm-hmm.
We evolved in a highly complex, competitive environment.
And that evolutionary complexity means human health is rarely just a straight line.
No, it's not. Our biology is designed to respond to subtle environmental cues, not just, blunt force chemical interventions.
Which brings us to the health and